previous lectures. Just at Canvas, just click on past meeting. I know you came here clicking virtual meeting. Click on past meeting. You could rewatch it. All right, so let's do this equal. We know very well. Yeah, let's start from easy. What is this guy? A circle with center, draw, and R 3, right? If you get the same answer, type yes, please. I'm pretty sure everybody got the same answer. So you're saying, Professor, are you kidding? You know? Yeah, I know. All right. Microphone. Okay, good. All right. So that's the one. And then, yeah, when you walk in, yeah, turn off the microphone. Part B, A in R3. All right. Graph this guy. Now, think about what we learned yesterday. What does it say? It says, regardless of your z values, my x and y satisfy this relationship, right? Think about it. Whether you're on the first floor, z equal 1, z equal 2, z equal 3, z equal underground, z equal -1, z equal -2, you know, underground, right? My xy must obey this rule regardless of z values. Everybody on chatting, imagine the picture. What do you call that shape? This shape, this equation, this called. How about in space? What do you call it? Everybody, 1, 2, 3, type it. What do you call that shape? Everybody type it. Come on, get involved. Hey, you guys are my good students. All right. You know, I know you're not cheating. Yeah, I know you understand it, right? I trust you. I know you understand it. Congratulations. All right. So what is chapter 12 is about? Imagine when you start, before you start Math 190, you learn about algebra, how to sketch, pre-calculus, how to do some simple calculation. Then we get into calculus. Think of chapter 12 is like algebra or space calculus, okay? Step one is we should know how to sketch them, right? Because later we're going to differentiate, integrate on this 3D shape. Make sense? Yeah, good job. I'm proud of you. So how do you sketch this? My advice, easy way. But here, Y and Z. And what's my advice? Cut about 4 to create the 3D effect, you know? This is 3D effect there. This is how you create coordinates system, okay? Right? So 0, here's what? 1, 2, kind of 3, right? -1, -2. When you just kind of tell the number mark, make sure it's parallel to the x-axis here, okay? But when you create this, make sure it's parallel to y-axis. It's like -2, -3 here. 1, 2, 3, 3, right? So yeah, you're creating sort of 3D effect. And then do this way. Yeah, when z equals 0, z equals 0, that's what do you call this guy? It's on the ground. On the ground. You know, on the ground here. On the ground, right? Z equals 0. X squared plus Y squared equal 3 squared. Okay. It is circular. So I think to create this effect, I don't think you want to do a circle. It's not quite right, right? So maybe you kind of draw something like this, something like this. And then when I go to, maybe let's say, let me go to what? Let me go to what? First floor, second floor, third floor, you know, fourth floor. When I go to fourth floor, what should I draw? Fourth floor, right? Think of fourth floor. This is my z equal like 4. What is the xy relationship? They are related to x squared plus y squared plus g squared. I mean, 3 squared. I see. On third floor, you still have to draw the what? Circular relationship. So think of, so far we study on the what? In Math 190, 191, we only study on the what? On the ground. Right? And now here, space, you still have a, yeah. So then how about you go to something like, let's say you go to what? How about the underground z equal below -1, -2, -3, -4, -5, something like this, you know, -5. You know, below the ground level here. Yeah. So here, what is xy relationship when z equal 5? Well, x and y obey this rule, you know. Oh yeah? Oh, you guys are just circle, okay. And do this. Something not visible for use as this outline. How's that? Just create 3D effect, you know? Cylinder. You guys are right. And it's going forever, right? Okay. If you understand this, type yes, please. Type yes if you understand it. That's what them. You are on the fourth floor, ground level, you know, you're on the what? Zero, -5, you know? I don't care. X and Y, they always make circle. Every floor circle here. Every floor they make a circle. Ah, you call this guy cylinder. Okay. So far so good? All right. Let's do part B. Let's do part B. Look at the part B. What do you call the shape of this? 1, 2, 3. Type the answer for part B. Troy? Yeah, you know what? I check you guys. I check the attendance. Also, I take the picture on you. What? Who's on here? Yeah, I record. Yeah. Everybody's type the name of this shape. 1, 2, 3. Type it up. Come on, everybody, type it up. Okay, good job, good job. So this is what happened here. The one satisfying this one, red, is this. That only what? Basically, this is what? This is what cylinder, you know, just what outside. It's like outside of Pepsi can, not the interior, right? This is the one. But how about the one z equal 4? It is this guy. All right. What is the intersection? And there's something satisfying this. Which one, which point? You know, they are made a bunch of points. What are the point of the green, on the red? That's right, Kayla. This is the question. What are the one making red? Red is only what cylinder, okay? G-equal format, it's all green plane. Kayla, what's the one you colored twice? Interior? Look at this. Outside is not. All right, let me see here. Outside you only color once. Here once. How about inside? It's also green too. It's not. How about only when you color? You color over this red. Isn't this the only? It's a circle. That's it. That green ring. This purple ring. This is the only one you color green and the red together. So it is a space circle. If you understand this type, yes, please, everybody. Yeah, this still is there, but how about the bottom one? You don't count because you're not z equal 4. So above, you know. The question is, what are the ones satisfying both conditions? You have to be on the what, 4th floor, but also you have to satisfy this. That's what, circle on the 4th floor. That's it. Okay, folks. Good job. So now I gotta challenge you one more time. Let's move up from this guy, okay? I want to ask you, I challenge you. This is my asking challenge. I want to challenge you. Write down the equations for this one. All right, everybody. All point on here. Let's write down this way. Don't you express all point on here? Okay. Let's write down this. Say it this way. Collection of all the point x, y, z, such that what? Write down condition right there. Maybe I should do it this way. Another better way is this. The better way you could say this is, how about this? All the points, maybe sometimes this is a good notion. All the point in the space, find what? All right. Good job, Cameron. Cameron, correct, everybody? Okay, then it is of this. What is this? This is what? Whole point. Equal is only what? Only can, right? But how about this? This what? Plus Coca-Cola inside, isn't it? Look at this. This is only Coca-Cola can. This is a Coca-Cola can. How about this guy? Coca-Cola can and cola, right? Can is what making equal, right? And how about cola? Cola is what less than 9, right? This is can and cola, but this is only can only. It's only can. But what's that? It's kind of on the 4th floor. If you understand this, type yes, please. How do you like it? Do you like it? Okay, that's good. So I think I talked enough about section 1. Yeah? Can I move on? Also, I have an office hour today, right after class, so you guys could stay and then we could do some homework problem together. Okay? So if you fully understand, you don't need to come to office hour, but if you think you need more help, come to office hour. All right, congratulations. We're done with 1 second. Bad, Okay, that's good. So vector, so let's summarize this. What are you learning here? I mean, oops. Chapter 12, space surfaces. Something like, hey, Something like what did it do? We did something like a paraboloid. I mean, some kind of shape thingy, right? Yeah, yeah. Okay, that's what 13 we do, and then we talk about vector too. Vector, we B W's, B cross W. Later, this one to study work, this one to study flux. What is a flux? Flow. Aerodynamic, hydrodynamics, electrodynamics, thermodynamics, whole physics books. So I think 12.3, and this 12.4. So this guy is like 12.2. If you understand this structure, type yes, please. Chapter 16. Chapter 16 is our climax. This is where we want to go. Because this is what? Physics 1A, 1C, 1D. That's where we're heading to. Yes. Yeah. It's obvious now. 12.3 is like A, that's like high school level vector. So chapter 12. So that's what we learned. Chapter 12, we learn about space curve. It's something like this is a space surface, right? But it's like space curve. Like, hey, what's the equation of this guy? Like what is a space curve? It's space curve. Space. And later we do something like this. Hey, what is a tangent line here? Yeah, what is a tangent line here? Tangent line here. Ooh, I mean, oh yeah, it sounds like a space tangent line. Chapter 14. Oh yeah, what is a tangent plane? Tangent plane. Tangent plane. Plane. Oh yeah. Tangent line. Oh yeah. Why care about tangent line? You're flying, you lose your control. You're flying this way. Supposedly you're the trainer of the Air Force. F-22, like hundreds of millions of dollar airplane. You better train pilot very well, otherwise they're gonna messing up this hundreds of millions of dollar aircraft. Right? So think about your pilot. You have to do space maneuver like this. How are you going to program the aircraft so that it follows certain step? 13. Make sense? And then chapter 14. Yeah, differentiate. Okay, differentiations. Why you want to do this kind of thing? So that I could find something like tangent line, tangent plane, and then maximize, minimize. Here, mountain, like kind of space mountain. Hey, can you find a local? Where's the maximum there? Max. Where's the minimum? Oh yeah, this is math 190. This is what space 190. Find maximum, minimum. Optimize, maximize, minimize, maximize what? Maximize what I like. Minimize what I hate, what I dislike. What is the thing you like? Something like profit, right? Yeah, all kinds of. What you dislike it, like expense, optimize. I think that's 190 in chapter 14. Make sense? And what do you think of chapter 15? Oh yeah, you differentiate? Okay, then I'll integrate, right? Integrate. Did you do this? Did you do this on Math 191? Why don't you do this in Math 220 then? Where R is something like R is some reason R here. So of course we have to understand what that means. Oh yeah? Then what if I want to integrate on solid like this, solid like this, solid E, I wonder what does it even mean by this? Okay, that's what we have to learn. Oops. Yeah, here, dx, dy. Oh yeah, y and z, dx, dy, dz. Chapter 16. What are you gonna do? The reason why I study this guy. The reason why I study this guy. All this. Why am I doing all this guy? Because I will try to answer two questions: physics, work, thoughts across across S. So sometimes yes, you know how to make blocks. Suppose it's a surface S. Surface. How much is the matter going through? If more matter is going through the surface or whatever, you create more energies, right? So we call flux across. Flux. Think about the perspective of energy. Flux across surface S. Right? We have this kind of, yeah. Here's a surface, a space surface. Work, okay, work is, force times distance, dot product, right? If you do some physics, don't worry, I'll talk about this. Work along curve C, while my things are moving around this curve C, how much free gasoline do I get from using gravitational force fields? Suppose that you're near Mars, you're gonna get free energies using Mars gravities. So how much energy do I get? How much free work do I get using gravity? Surface, when charges are going through this one, how much metals are going through this? Cross product. And this is the entire physics. Okay. Flux, again, thermodynamics. If heat go through here, thermodynamic. If air molecule go through, aerodynamic. If water molecule go through, hydrodynamic. If the electron go through, electrodynamics. This is the way we generate our energy, right? Yeah. If you understand this overview, type yes, please. That's where we're heading to. So that you could tackle all physics A, B, C, D, physics A, B, C, D. Okay, so just have this roadmap. So now, I understand. Oh, so you may wonder, oh gosh, why do I have to study this suddenly vector? Oh yeah, because you need to know vector first so that you know how dot product and cross product. 12.3, 12.4. Oh, okay, I get it. All right, everybody, let's do this. Vector scale. Okay, define the difference between vector and scalar. One more time. Okay, folks, go for it. All right, everybody, look at the chatting. Okay, look at the definition of your classmate. And I think many of them took the physics. They know. All right, if you haven't taken any physics, never done this one before, learn from your classmate. Read through their definitions. Okay, read their definitions. Yeah, I'm taking the photo on your attendance. So, I know who is here. Okay, good. Yep. All right. Good job, everybody. Thank you so much. Yeah. Yep. Scalar. So vector has both has magnitude. Yeah. Yes. What is the magnitude? Something like a force case, like 5 newtons. 7 newtons. Yeah, it's bigger. 7 newtons is bigger. How about scalar case? $5, $7. Hey, you're bigger, right? Yeah. Magnitude, right? Yeah, both have magnitude. Okay. The force is a 5 a 7 Newton. How about directions? 5 Newtons force. You push something to this directions. 5 Newtons. Say this is the what? F of 1. Okay. Force, right? You push the force this directions. Magnitude 5. The same magnitude, but they're different vector because you know that you get different results, isn't it? What I'm talking about, type yes, please. Think about it. You have four same magnitude, 5 Newton, 5 Newton. Doesn't direction matter? I mean, look at the consequence after you're pushing a certain direction. Direction matter to vector. So how about this? Oh, I spent $5 in northeast. I spent $5 in south. No, you don't have it. What the heck? It's a what? North $5 and the south $5. There's no such a thing. $5 is $1. That's called scalar. Oh, today I spent $5 northwest. What? Oh, I spent $5 southeast. What? Direction doesn't matter. That's just called scalar. Okay. If you understand my argument, type yes, please. Yeah. So we start to understand when you talk about physics, like motion, direction, acceleration, velocity, all those, we have to think about direction too, you know. So by adding magnitude, I know 5 is less than 7. I know that. But furthermore, talk about what directions. Yeah, we have a component. Vector expressing both of this category. Scale, $5, $7. You don't have a direction. No direction. No direction. Makes sense? Okay. So let's start from just basic stuff. I took some of the picture here. Here. Vectors with the same, they're same. So basically, these guys are all same. Yeah, they were same. So think of this way: you're flying, okay? You're flying. You're the pilot. When you hit by this guy, when you hit by this guy, I think it's the same. So suppose this way, with certain force, I think you're affected the same way by this wind blow, this wind blow. If you understand what I'm talking about, type yes, please. You're the pilot. Think about wherever you are. You're gonna be affected the same way. So interesting about location doesn't matter. Location doesn't matter. These are same because they're gonna influence your aircraft the same way. Location doesn't matter. Makes sense? Yeah. What matter is direction, magnitude. So we created this amazing tool. I mean, people know this. Think about it, right? Think of this. This is what? Let's say this is a here. Let's say this. What is the magnitude of this guy? Magnitude. This is the magnitude of this is. So use the Pythagorean theorem. Okay, everybody use the Pythagorean theorem. 1, 2, 3. Type the answers. Yeah. What is the length of this? Length of vector v. I use the Pythagorean. like this here, you know. Is this is a 3 and the 3 and the 2? What is this? It's like this, right? Magnitude. Yeah. The length of vector. So yeah, you know. Yeah, square what? Square root 13. Yeah. Yeah. Some silly thing like this. Square root 3 square plus 2 square. And plus 4 13. Yeah, this is the one. How about this one? Same thing, right? 3, 2. That's what they're all same thing, you know, right? 3, 2. Yeah. Find the data here. Find the data. What angle? Okay, find the error. Angle. Okay, everybody find the angle here. What is the direction? So we got direction here. Directions. Give me the direction. Everybody give the answers. Just look at this. This is what, you know, I think this is all data. Triangle. Yeah, so find data. That's the directions. They're all same. Everybody give me the angle, direction, where. So supposing you're a pilot, you definitely want to know the direction of the wind blow, isn't it? Think of just a wind blow, okay? Wind. You know, wind blow. You know, wind blows, you know, so many things. It's the same direction, right? I love it. So what are the directions? Wind is blowing. I know it's going to affect my plane, aircraft. I'm a pilot. Yeah. You got it? Okay. 33.69. Okay. All right. Thank you so much. So how do you do this? Data. Yeah, you know, tangent data equal 2 over 3. Data equal tangent inverse 2 over 3. Okay, done, you know. So what's that? It's about what? 33.7 degree? Okay. Think about it. Why they are same vector? Here's my conclusion. Why they are same vectors? Because they all have same length. You know that. Think about this W. This guy W. What do you think? This guy has. I know this guy W has what? Same what length, right? Right, 13. I know this data is what same because why? They are parallel, right? Parallel means same direction, isn't it? Yeah, they're parallel, same direction. It is the same thing. It's the same thing here. That's what I'm saying. W, W, and then V, you got to be same vector. Because you got same length, right? Same triangle. You got that triangle? Okay, I'm this triangle, you know? I mean, I'm same too. I got the angle theta just like you, W. I got 3 at the bottom, 2 at the top. The length of this called, I mean, this arrow is called W, vector W, right? But magnitude is it's a scalar. And we're same, you know? If you understand this type, yes, please. So what is section 12.2? All right, let's think about this one here. Why we're doing this silly thing, you know? Gosh, yeah, you know. Section 12.2, it's introduced vector, right? Then section, we're gonna go to what? Building dot product and cross product. This is section 3, section 4. And this is gonna lead to chapter 16, right? Yeah, flux and then work. Okay, that's how things goes. Okay, so easy. All right, I got it. I understand it. Any questions? Can I show another interesting thing here? Watch me. Why they are same? Okay, this so it's one way to know. Oh yeah, they're same. They got same angle, you know, same, you know, magnitude. Okay, folks. Let's find out. Let's find out what V is here. This guy V. Terminal points. This is called terminal point. This is the initial. Okay, this is what this is called. Ending. Terminal ending, right? Terminal point is the starting point, initial point. It's always terminal point minus initial point. Check this out. 4 minus 1, comma, what? 5 minus 3. The vector is 3, comma 2. Yes? Check this W, folks. All right. Calculate what W is. What is this point? 1, 2, 3, 4, 5. Negative 5. That's the initial point. And then X is 1, 2, 3. Negative 3. How about terminal point? Negative 2, negative 1. Okay. Find this vector W. Calculate it. It is always terminal points, terminal points minus initial starting point. Initial point. Oops. Gosh, why you're going? Okay. So what's that? Negative 2 minus negative 5, you know. Negative 1 minus negative 3. What do you get? You get 3, comma 2. What the heck? That's what they're saying. If you understand this type, yes, please. It's always terminal minus. It shows again why they're same, you know. They're all same guy. This guy's all same. It's always terminal minus initial. So I guess our favorite guy is this guy. This guy is our favorite guy. That's why, you know, sometimes, you know what is the best way? Just place what? The vector to the what? Just move. So when you have an arrow, just move around. Move around this guy. Move around this guy. Move around this guy on the top of here, you know. Put this guy at the what is the origin. I think it's pretty similar. Let's say this is a vector u. What is this? Don't you think it's a pretty good idea? 32 right there. I mean, it is what? U is basically terminal point 3, initial point 0, terminal 2, initial 0. If you locate vector initial point on the origin, you know that terminal point is always same as vector. If you understand this type, yes, please. Yeah. So it's still a thing, you know. I think that's how we start. I mean, we start from this like high school level math, and it's amazing we build up to blocks that work. Wow. So what you realize is here's one. Okay, steady. What we realize is steady. Point is this 3, comma 2. It is a point. It is like simply a point. It's a 1 point here. It is a point. Okay. But oops, I didn't do it. But when you put something like this bracket notation, 3, comma 2, it really means it is arrow. It's a different guy. You check this out. Point, this is what, comma 2, right? That's only ending point. This guy is the only point. But this guy, the whole arrow. Does it make sense? Yes? Yeah. So that's how to define vector. So I think we made up this arrow showing, you know, how do you express something has a direction and magnitude. So we made it up. We made up this arrow thing. Yeah. If you have what? We noticed that if you put arrow, you can move around anywhere. They're same thing. These are the whole same thing. You know, as you get same direction and length, they're same guys. Okay, it's like you hold your pen and move around. You know, same direction. They're same thing. But smart well is if you put the arrow on the from 0, 0, then we know this is also a same as like same, isn't it? Yeah. Any other questions? So far so good? All right, good. Yeah, X component, yeah. Yeah, you're right. That's the point, Seti. Yeah. The issue is this: if you think of this one, Seti, you're the pilot. You're flying. Wherever, I mean, impact of this arrow, right, to your aircraft, location doesn't matter. If they're blowing same as what 30 miles per hour to northeast, wherever you are in fact the same way as a pilot on your aircraft. It's your same vector. So vector case, location doesn't matter. What matter is as long as they have the same direction, same length, then they're same vector. Because your plane get impacts the same at the same magnitude. Right? Okay. All right. So a simple thing is this. All right. Suppose that this is a yeah. So we're learning this new mathematical tool. It's, suppose this is a V. What is 2V? Yeah, just double it. Yeah. It's twice. How about half of it? Oh yeah, I get half of it, right? Same direction. How about negative V? Hey, go this direction. How about how about the negative V? Hey, just go out, and then what was that? This is about one. Then this is like a yeah, about this much. Okay, if you understand this, type yes, please. Yeah, it's just like I know this is how it starts. So I think what's going to happen next 16 weeks. What's going to happen? Calculus is a very challenging course. At UC Berkeley, we teach math 50, math 270 first, and this is the later course, 220, math 220. It's a very challenging course, but I'm a magician. You know why I'm a magician? Because you're gonna all understand my lecture next 16 weeks. Let me show you my magic. You'll be surprised. You will understand every single thing I lecture. If you trust me, type I trust you. All right. If you think I say the words, you will understand me. Okay. Trust the word, type the words I trust you. Because I want you to be happy and succeed. And someday I want to see a NASA, SpaceX. I want you to be the in frontier of the human expedition in space. You can do it. Okay? And you can do it. So let's work together, okay? Particularly this on the COVID-19, we're very stressed out. So go to Q&A every week. Look after each other, please. Because I know that watching your communication, I know who has a good heart. You have a good heart, you're gonna impress me. I'm gonna make sure you succeed. I like the people that have good heart. I like those people. So I'll watch you, whether you're really helping out, look after one another. That matter. And I'm gonna think about myself. If I have to hire someone, who should I hire? I like the people that has a good heart. Willing to go extra miles for other classmates. We know that you'll say that throughout the semester, someone will struggle. Yeah, if you're a really good person, you're really good at math 220, help them out, offer them extra help. When you train your good practice, wherever you go, you practice the same way, you'll inspire a lot of people. And then you'll be the leader of the organization, wherever you go, Raytheon or SpaceX, wherever you go. Another one, I have a lot of friends in NASA. The way they hire people is the team. They look at the what? They hire the people together in the interview process. Who they hire? The people who knows how to teamwork play. They don't like solo. They don't like people with solo. Sorry, you don't belong to space, not NASA. You should know how to work together. Okay. SpaceX, same thing. Yeah. Well, thank you. Okay. Thank you, Troy. President of Mars. Okay. So get involved. Also, teach yourself how to get interacting with other people. I see. Maybe I could pull my son, Alex. He's currently at UC Berkeley, mechanical engineer. I saw him interviewing and orientation and teamwork like projects. Maybe we could hear from him how to succeed at UC Berkeley. He's a mechanical engineer. He just transferred from El Camino. And then I saw him working on the teamwork project for 2 weeks of the summer. I realized communication and teamwork is critical. That's what I sense. That's why I think Berkeley engineering program will train their students. I noticed that. So maybe we could invite him sometimes this semester. Maybe we could hear from him. Right? Maybe he might give you some advice to you guys. Okay, so let's go. Okay, so now you know then how do you add a vector, right? Adding vector is this. Suppose that, all right, so here, what's u plus v, then go to u, starting from here, you know the vector, suppose this, vector u is here, vector right there. What do? You cannot attach them here, you just move, vector we could move around, right? So you just u there, v there, wait, connected, starting, and the initial point for the or v. If you understand this, type yes, please. Yeah. Yeah. Okay. Yeah, that's good. All right. By the way, I told you I have three sons, right? I have three sons, and then they all came to El Camino. They all took Math 220. So my first son, Matthew, he went to UCLA as a STEM major. He graduated. My second boy, Isaac, he took the Math 220, El Camino too. He went to UC Berkeley as an econ major. He graduated. My youngest one, Alex, is now third year at UC Berkeley. He took Math 220. So El Camino is doing a pretty good job, and you guys made the right decisions. You are really helping you out. Also, you're helping your parents too, right? Saving lots of money. Great decision coming here. Good decisions. Notice this. Right? Another way. One way, triangle. You could draw a V. Doesn't matter, right? The same direction. Parallel. They're parallel, right? And they're same in length, right? Yeah, that's why these guys are same. Basic, yeah, isn't it geometry, right? Why this is a parallelogram? So what do you know? Hey, parallel and same in length. You got to be same vector. Parallel, same in length, parallel, same vectors. So then draw the parallelogram. Draw the what? This what diagonal, that's u plus v. So one thing also we notice is, what do you notice here? Basic stuff. U plus v. Okay, let's call u plus v. How about v plus u? No? Yeah, it is. Yeah. Not sure if this is on topic or not, but algebra geometry. I don't think. I think Kayla. I don't think they teach it, but some school they do. Some honor algebra class, It's just basic geometry. So you realize what u plus v, and then v plus u. We know they're the same. We know that they commute, right? Okay. If you understand this, type yes, please. Oh yeah, Baron, you're right. Yes, some school they teach, some other school they don't teach. Baron, do you know? So if you learn it, that's good for you. But some schools I know they don't teach vector, even though this is such an important topic. Okay. So the same thing for here. Here this is interesting here. How about this picture? Here. Go to A, right? What's plus 6? Go to A, come to B, right? Oh, yeah. Start, So it's always like at this point is like starting point, right? Suppose this is example. How are you gonna look at this one? Check this out. Yeah. What is a realistic situation like this? Suppose that you try to fly here. You try to fly here. You try to fly. You're the pilot, Okay, pilot flying. Then what happened? Wind is blowing. Yeah, wind is blowing this way. Wind. You know, wind is blowing this. So what happened? Yes. If you understand this, type yes, please. Does it make sense? Yeah, think about it. You are intent. That's what you're the pilot. You have to think about it because what? There's always a wind flow. Air. What is a wind? It's like air motion, right? One point to the other. Right? So think about it. Another thing makes sense is all right. So now here you pilot. You want to go there, but wind is going this. Then you actually end up going here. You actually going. You end up flying this way actually. But suppose that you're going. Um, what if this one kind of makes sense? Here, what if the window is only blowing only this much? Window is only blowing this much. Okay, it's the same. This is the B. And where are you heading to? I think you like this direction, isn't it? Yeah, you are actually heading this way, right? What if the wind is blowing? What if the wind is blowing this way? Where are you heading to? That's the error. So I think if your wind is strong, then your course is off. But if wind is blowing a little bit, right? It's just a little, then you're course. So as a pilot, you have to calculate this. Suppose that this is where you want to go. This is what maybe this is LA. This is like suppose this is like like a Seoul, something like that, right? I think you have to fly this way if you're going to Seoul. Okay, if you understand this, type yes, please. You have to calculate wind together. So don't try to go there. You try to Seoul is there. Let me fly this way. Well, you're gonna end up Australia. You're gonna end up Sydney. You understand it? Yeah, you understand it? Yeah, you're gonna end up Sydney, Australia, not Seoul. Okay, so that kind of makes sense. Yeah, same thing for this. Yeah, same here. So another way is this. I think when you have vector, let me summarize this one more time. Then let's move on to silly thing. Vector location doesn't matter. One way is again, yes, this vector you're kind of ending. Well, put the initial for the V, and then terminal for. That's how you get this guy. Another way is what you put U there. You put initial point, and then draw the parallel and put the diagonal. That's another way, right? So again, one more time. One, bang. That's one way. Another one is what? You do this. Oops. This, and then you put this, right? This guy, and then make and then bang. That's one. If you understand this, type yes, please. I'm pretty sure everybody understands it, right? Okay. So now, quite interesting is this. How do you add the vector in coordinate system? Check this out. This is quite interesting, folks. Watch this one. I mean, think about it. Here, let me ask this way. Suppose that let's say vector A is maybe 3, 3, 2, and vector B is let's say this is like a maybe 5, 5. Let's say 5, 5, 4. Okay. What do you think vector A plus B? All right, everybody, guess and type the answers. 1, 2, 3. Type the answers. Yeah. All right. What do you think this guy is? All right, type it up. What do you think this is? 8, comma 6. Yeah. Matthew, put the bracket. Okay. All right. James, yes. So easy to say, right? Yeah, okay. Yeah, you're right. You're right. Everybody, congratulations, you're right. But you think it seems a bit too easy to say. So, really? Does it really work that way? I know you did. I know what you did. You did what? 3 plus 5, right? 2 plus 4, Sounds so sounds so easy, right? But you may wonder, hey, is that really right? I mean, is it really consistent way I adding vector like this? I'm just wondering. Wondering, are they really consistent? Check this out. Think of vector A as A1, comma A2. Think vector B as B1, comma B2. So really A B is really A1, B1, A2, B2. We start to wonder. I mean, yeah, I wish it's true. Check this out. Let's put vector A. Here we go. A. And then put the vector B. B is what? Vector A is what? A1, A2, right? Vector B, location doesn't matter. B1, B2. What is this guy? This guy is a B1. So what is the length of, what is this vector here? Think of this like 0, 0, right? This vector is this. What is this what? X component. Really A sub 1 plus A sub 1. Really, we're adding this. How about this here? Here's A sub 2. And then here's A sub 2. Here's a B sub 2. Really adding this. It really does this. It works, really. We are actually adding the coordinate. They're really true. They're really true. If you understand this, type yes, please. It is so true. The silly logic, true. Surprise, it really. It is true. Wow, 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 it feels so good. Oh, wow, that works. That's nice. Okay, how about this? Why don't you do from A? All right, let me see who's going to get the answer for this one. Why don't you double the what? Double A. All right, everybody, type the answer for 2A. If you double this vector A, 3, 2, what do you think of the answers? And you're right. All right, write down the answers. Yeah. All right, look at the chatting and then everybody chip in something. So you say, okay, all right. I mean, I say it, but is it really that silly logic works? I mean, I know I did it. I did really 2 times, right? Right? I kind of you kind of little feel guilty. Really? It just silly logic works? Really? 2 times. 2 times. I want to say that, 2 times 3 and then 2 times 2. Does it really work? Um, yeah, it really works out that way. It really works out that way. It is simply why this is true. It is really A plus A, right? Isn't it? The vector double A what? Double, double. Yeah, it is really simply adding what? Vector 3, 2 plus 3, 2. And because of this, it is really adding. It's really adding. When you add it, you're gonna get this and this. If you understand this, type yes, please. Yeah, that really works out that way. So let's keep building up the silly argument first, okay? Subtraction, kind of think about a little bit. Subtractions. Oh my gosh, time flies. We only have 10 minutes. Subtraction. How do I do this subtraction? One way is this. One way is this. Okay, so u plus. Okay, say this is v. It is so true here. If you have 3, 2, what do you think about? Say this is vector. How about negative v? What's the negative v? Negative v means something opposite, right? We know it's going to be what? Negative of 3, negative 3, negative 2, right? That makes sense. So scalar multiplication, I could think of this one as a negative 1 times b. Really, that works. So maybe one way you could do u minus v is, how about u? Yeah. So here, if that's a u, make negative v. The same thing here. Or you put negative. It's this guy. If you understand this, type yes, please. All right, type yes if you get it. Yeah, just make it negative v and add it. Same rule. It's addition. But I suggest this way. Now I think we should kind of think of this way. We have a u when you have v, u. Okay. My suggestion is this. It is a v. Put them together like this. And then I suggest this. Connect this. So write down u, let's say u minus v. You know what you should do? It is this. How do I get this guy? What do you put the arrow? Question is, should I put the arrow up or down? I mean, I'm just wondering. Is it this or this? Right? I just wondering. It is b plus something. If you add this two guys, check this out. B plus u minus v. Think of this one vector. It becomes u. So it should be going this way. See? B plus u minus v, that's u. If you understand this, type yes, please. Does it make sense? Let's say this. U and v. How about v minus u? All right, can you draw v minus? Yeah, don't look at this. You kind of draw. It is something. It is what? Connecting terminal point. Connecting terminal point. All right, which way? It's going up or going down? I think this way. It is you add this to then we get there, right? Because here's u there, so I think we need to add this, guys. So add this, you add it, then you kind of cancel this out, v. So it should be up there. So think of it this way. Okay. All right. Any questions? Magnitude. I mean, we did already. So all right. For here, times 4 in 2. Yeah, let's get out from this simple thing as quickly as possible. So here is what. Yeah, use a silly this what. This is a A1, this is A2. 1, 2, 3 answers. Okay, if you got the same answer, type yes, please. Type yes if you have the same answers. Okay. All right. So yesterday we learned this magnitude in R3. Okay, so question is basically what is the length of this arrow? All right, everybody type something. So yesterday we learned distance formula between 2 points, isn't it? Yeah. So Pythagorean, right? So this magnitude of A turned out to be by Pythagorean theorems. Yeah. Right? Where did I make a mistake? Why do you write ln? What is ln? Oh, yeah, okay. So ln mean maybe instead of ln, maybe on, not on. In space, in plane, on the plane, maybe on the plane, in R2. That's what I mean. Any questions? Easy? Okay. So here we have a unit vector, length one. Okay, so this guy is important. That is vector J. That, yeah. So here is what is the magnitude of I? Unit mean length one. So this is length one, right? J or one. So we call this a unit vector, INJ. The important thing is a vector. Check this out. Vector A is A sub 1, 0, A sub 2 minus 0, which is A sub 1, sub 2. Maybe think this way. A sub 1, 0 plus 0 comma A sub 2. A sub 1, 1, 0. A sub 2, 0, 1. A sub vector I, A sub 2, vector J. If you understand this notation, type yes, please. Yeah, we could write I and J. Like I component is for unit parallel to the X, J is what? Unit vector parallel to Y. You could think of this way. Okay, folks, give me the coordinate for I. 1, 2, 3, type it up. What is a unit vector? Something parallel to x-axis. What is that equal to? What is I? In space. Yep, 1, 0, 0. J is 0, 1, 0. Okay. And K is 0, 0, 1. Their length is all 1, right? And then we know the same way. So when you have a vector A sub 1, A sub 2, A sub 3, I think these are same notation, basically. Yeah, very good. Easy? And then all length is 1, right? Yeah, they're all length 1. So that's what we call a unit vector. Unit mean length. Okay. Oh my God, time flies. Any questions? Okay, so I guess these are the properties. So I guess we have to quickly learn this one. Section 12.2 and 12.2. So we have to go. Okay, this is a section 12.3 and 12.4. Okay, that's where we're heading to. So let's do this. All right, everybody. 1, 2, 3, typed answers. Commutative vectorization. What's that equal to? U plus V equal. What do you think I'm going to write down here? Everybody, type something. Commutings. What do you mean by commutative properties? Yeah. Yeah. Aline, yeah, you're right. Yep. I mean, think about it, I think in general, right? Not only what R2, suppose that U and V is the same as what? Suppose that U is A sub 1 through what? A sub n, right? B is what? E sub 1 through E sub n. This is what? A sub 1 plus B sub 1 count all the way down to A sub n plus B sub n, right? I mean, you could switch order, right? Because the real number they commute. And then you could separate them as well. B1, Bn, A1, An. What do you call this? V plus U. So this is a general proof for this. Okay. If you understand this argument, type yes, please. All right. So I guess I have to stop. Yeah, let's continue our discussion starting this. So homework, make sure you do 12.1 and get into 12.2. Okay, guys. I'll see you. How much did you understand my lecture today? 0%, no idea, 100% everything. Let's quantify your level of understanding for today's lectures. Okay, everybody, give me the number. And look at the data, and then you could sense that where you guys are standing, right? So your classmates are quite smart, you know. They all get it. Like almost 100%, everybody. All right. Okay. Homework. Just that I collect the homework next by next Sunday. So you know, 12.1 you need to do it. You need to finish. But 12.2, work on it. I mean, I'll lecture more tomorrow. Okay, so I'll see you tomorrow. But I have an office hour at starting at 45. So we'll take a little break. If you wanna go over some home problem together, stay. All right. Have a 3-minute break. We'll come back after 3 minutes. Okay. So everyone, okay. So I have to start the microphone. So why don't we try out this question? Why don't you sketch this shape? Oops, I think I made a mistake. This is a 2, sorry. Let's say 2z. I didn't assign this, but let's study for this, okay? All right. Everybody's, once you're done, I want to see your, it is what is this? This is what the 8th edition blue book, 8th edition blue book, right? 8th edition, it is blue. Your math 191 textbook is a transcendental calculus book. Yeah. Say. Okay. So Troy, what's this? Let me turn on the camera here. Yeah, Troy, do you see this? This is our book. Yeah. Yes. Do you see it? Yeah, yeah, this one, yeah. Okay. You know, Taeyeon, that's fine. Taeyeon, if you don't have student IDs, just do this. On a piece of paper, you for your book, right? Because I was and write down your name, and then your EC, yeah, and then just take a picture. Okay. All right. Let's try this. All right. I wanted to sketch uh this equations. Take a few minutes and then show me your drawing. I want to see. All right. Take a few minutes. Okay, everyone. All right. Let's see. All right. Let's see where you are. Okay. And then, yep, yep. That's good. See, that's how we do it. Talking each other. Very good. So it's an algebra question, right? Isn't it? So what do you realize? You put, x squared, and then, yeah, let me put here y squared, g squared. I mean, let me look at it this way. 8x equal -17, right? I put, what's the half of this guy? 4, right? So 4 square. So add 4 square here. Yeah, add 4 square. And then what do you add here? Negative 3 square? You know, you got to always half of this guy square, half square, to get to make it perfect square, right? Half square, which is what, 4 square. Half is this. So add half of this. Half of this. 1. Okay. So x plus 4 square, y minus 3 square, g plus 1 square. Did you get this? Negative 17. All right, what is this number here? Negative 17. Oops. Negative 16. 9, 1. Wipe this out. 9. All right. If you got the same equation, type yes, please. Type yes if you have same equations. How many people are here? 9 people, okay. Okay, so Justin, questions. Justin, here we go. Justin, click on annotate. All right. All right, click on annotate. Indicate where you're struggling. Okay. Ask me annotations. Justin, click on annotate. Okay. All right. Use a whatever color pen. Show me where you have trouble. Indicate it. I'll repeat again.
Okay.
Right.
Let's see.
Use the highlighter and then indicates which line bothers you.
Let's say this one.
Okay, highlight it. Okay. All right, that's it. That's the only line.
Well, and as well, like why you did these steps.
Okay. All right. Good.
Cool.
So here we go, Justin. This is a reason, Justin. You know that you learn about the completing the square, right?
Yes.
Yeah. So completing the square. Why we do always half of this guy in square? Because if you do this, what happens? It is what? X plus 4 plus x plus 4. It's a factoring. Isn't that right? You know? Yeah, if you have a half of it, you could always get. That's the reason.
Oh.
You got it? And then look at this negative 6 here. What is this? This guy's are literally, think about this factoring. X minus 3, x minus 3, you know?
Right.
Yeah, so this is what obviously the same as what? X plus 1. I mean, you may still wonder why you're doing this, right? Of course, you know, you should have that question. So we end up getting this square, 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 okay? Does that make sense?
Yeah, that makes sense. Okay.
Yeah, then, you know, this number equality, I just add the same thing here. You know?
Right, you have to add on the right side. Okay, thank you.
So then we get that, what is this guy here? Okay, folks, let's name this one. What is this guy? Okay, what do you call this guy? Please name it on the chatting. What do you call this shape? If you sketch it, what do you see? Do you see Pokemon or box or what do you see? Sphere. Everybody type the word sphere. It is a sphere. Justin, do you see this one? This is the reason. In mathematics, when we to some, I mean, question is, I have to go through all this. Why? You may wonder, why do I have to do this? You know, that's the question. My original question, I don't know what this guy is. I don't know. But once I changed the format, I didn't change anything. We recognize this guy is here.
Okay.
What is that, folks? What is the center? The center. What is the center? Everybody type it up. What is the center of this sphere? Folks, type the center of the sphere. Yeah, it's opposite sign, right? Negative 4, 1. We know that this is the center of the sphere, right? And what is the radius? Sphere has a radius. What is the radius, everybody? Radius are equal to one number, 3. Does it make sense? And then we have to sketch it. That's it. So, what if I sketch this one? Right? Yeah, we sketch it. Yeah, so let's sketch it, and I want to see your shape too. So how do you sketch this? I think smart move. Let's plot this with a can. All right, what's a good way to sketch this? Okay, so my was here, right? I put this as like a Y, Z, right? And then what was my good? 45 degrees, almost 45 degrees. This is X, you know? Yeah. Okay, so center, mark the center here. Center is -4. So 1, 2, 3, 4. -4. Yeah, right there. And then +3. 1. Make sure it's parallel to the what? Axis, okay? Here we go. So here is the what? That's 3. So this is a -4, 3, 0, right? So then what happened? We have to go down 1 unit down, right? So you could just say one unit down, something like this. I don't know. This is right. And we could make something like this, right? Yeah, isn't it? 1 unit down. Here's -1. Then it is really -4, 3, and -1. So we got the center. Oops. Yeah. Then what do we do? The radius is 3. So I don't know. I'll do this. You know, approximately. We don't need to be perfect. I was thinking about maybe here from the center, maybe about 3. You know, right? And the crease like this, draw this like this. How is that? Huh? How's that? Yes, good idea. Spear. You know, how's that? How do you like this, my drawing? How do you like this? Yes, I don't know. I might just raise this guy something. Not okay. Clean up little mess here. You know, I don't know. Yeah. I mean, you know. Yeah. How about this? How do you like my drawing? Huh? You got it? Yeah. Can you guys turn on your camera? Can I see yours? Show me your drawing, okay? On your camera. Let me see yours. I want to see it. Show me. Yeah. All right. Annabelle, Rio, get it closer. I cannot see it. Good. Yeah, very good. Okay. Justin and Min. Damon, make it closer. Okay. Now, James, show me. Lift it up, James, a little bit up. That's very good. All right. Maria, Kayla, can I see your shape? Or Justin, Min? You guys did a great job. Yeah. Okay. That's good. How do you like this exercise? So I think, you know, office hour, let's think of this like a test prep, okay? We'll discuss the homework problem, but also I think more people will join us later. So that's good. That's good. That's good. That's good. All right. Good. So let's go to different questions. What else can you try? Okay, let's try. I want to try number 37. Number 37 is a homework problem. Okay. Let's try number 37. Number 37. Let me see. Yeah, just little by little, then you're gonna win. Number 12. This is a sum. Okay, sketch this one. Okay, take a minute and sketch this one. And then it says, describe in words. What is this? What is this? Okay. And name it. Name this guy. All right, take a few minutes. Good luck. Okay, so let's see what you got. All right, okay, so on chatting, name the shape of this object. All right, 1, 2, 3. What is this one? Cylinder. Good. Yep, yep, yep. Karen is correct. Yes, James, you're correct. Ning, you're correct too. All right. So inequality means basically with contents, right? It's not empty can, isn't it? So let's look at what it's like. Okay. So think of this way. How should I look at this? As regardless x and y, I think we have to first of all think about, let's say, we have to think about plus y squared equal first, isn't it, right? And inequality means basically inside what this shape, isn't it? So you said regardless of x values. Okay, when x equal, when here, just when x equals 0. When x equals 0. No, it's not x equals 0, right? Regardless of y value, right? It's about when y equal, oops. When wall, right? Well, y equals 0. What is it? X and, oops, I made a lot of mistake here. Z, right? It's a Z. There's circle on xy. It is what this one here. I think I could think of. It is a circle, isn't it? Radius 3 circle, isn't it? 3, 3, negative 3. Negative 3. So then let's move to maybe another plane here. Maybe my plane is something like, maybe, y equal, let's say y equal 5. Y equal 5. What is y and x and z relationship? X and z relationship, that's still circle. So, and then you have a lot of plane. Let's say here in the back here, I have another planes. Maybe y equal, where the pen goes? Y equal maybe negative 2 or something like this. What is that? X and y, x and z relate that way. So what do you realize? This guy is so I think you could make something like this. But now, is there only cylinder? I think we have to say cylinder and then what? That's then, right? So what does that mean? It's a whole thing inside the cylinder, isn't it? Yeah, whole thing. It's not only this, but also what? Maybe can with all the contents together, isn't it? So it is a cylinder and then its contents along the y-axis, isn't it? Yes. If you understand this, type yes, please. Type yes. Yeah. Okay. Does it make sense? Yeah. So later, what we do is in chapter 16, say this is solid E. Solid E. Chapter 16, this is what we do. We find the flux, Say this is like a chapter 15. Chapter 15 case, we do this. Chapter 15. Why don't you find out? Here's a question, chapter 15 question. Let me give you one example. Suppose the solid E, suppose it's density function, densities. So this is densities. Suppose that this is the one made of a whole bunch of different material, okay? The density mean is something like this, kilogram per cubic meter. This is density, how dense, and what volume? Volume is what? Cubic meter, right? Cancel this out. This becomes total mass of this guy. Maybe total mass. Maybe if E is from, maybe X is from, Y is from negative 2 to 5, something like, what was that? Maybe up to 3, up to 5. Yeah, so that's what we have. We just find the total mass of this guy. Suppose this is density function, kilogram per cubic meter, and volume. Cancel this out, you get total mass. That's what we're going to do in chapter 15. Make sense? If you understand my argument, type yes, please. Yeah. So not to worry about this at this point, but it's coming. So obviously, step one is we need to know how to sketch, right? That's what chapter 12 is about. Okay. Good.
Quick question.
Yep.
Where's the how does the 9 get incorporated in this problem? Like, is there a limit on the y-axis the cylinder can go, or is just the 9 there for the radius?
So this is what happened. That's a good question. Okay, here we go. So we see x squared plus y squared equal is less than equal to 9, or x squared plus y. I'm sorry, it's not y, it's z. Z. Let's think about it's 3 squared. All right. Let's think about what does that mean. It says regard less y values. X and z must satisfy this relationship. So look at this one, green one, the sky blue one. There, X and z must be satisfied this relationship. What is that guy here? Basically, X and z, it is circle, right? 3, -3.
Right.
Instead of y, yeah. And then what that means is on blue plane, you have to draw the circle, right? In this blue plane, on this blue plane here, right? How about on this blue plane, which is a y, okay? What is y and x and z relationship? It must be a circle there. That's why I drew the one, this tiny blue circle there, okay?
Right.
Then let's go to green plane. How about this green plane? Green plane, I say y equal 5. What is the x and z relationship? Drew this guy too here. They say
it has to have a circle.
Y values, right? And then how about the yellow? It's not. Is it yellow or brown? What do you call this color? Brown? What do you want to call it? Blood? Gold plane?
Gold? I don't know.
Gold plane? Okay, yeah, gold plane. Yeah, gold plane. Why gold negative? This guy, whether you have gold color, blue color, green color, I'm going to continue to draw a circle, So what does that mean? Think of this infinite many pages. What happened? You continue to draw the circle here, along. Infinite many of them. Infinite many ring of the circle. What happened? You get cylinder. Does it make sense? What do you say?
Yes, it does. Thanks.
Yeah, that's what I'm saying. Yesterday when I mentioned, think about this one. Y equal 2 kind of question. This kind of example, what does that mean? You know what it says? Let's learn lesson from this one. It says you pick whatever x value you want, but I'm not going to change my y values. X equals 0, I'm going to plot 2. X equals 1, I'm going to plot 2. X equals 2, I'm going to plot 2. X equals -1, I'm going to plot 2. What does it say? Regardless of your x value, here, my y, that's why this guy become line parallel to x-axis. What do you say? Can I say the same logic here? Regardless of which color plane you draw, I don't care. I'm going to always draw the circle, How do you say that? Huh? Yeah, no matter what value is, you're going to have a circle. Just right. That is the correct. Just like this guy, regardless of your x value, I don't care. So we get this horizontal line here. What do you say, Justin? Make sense?
Yes, it does. Thank you.
Yeah, that's right. This is important because I think mathematics, once we get it, we get the whole thing. We get the whole system. So let's from this kind of thing in algebra. Think about why it's a parallel line to x-axis. It doesn't matter whatever your x location. I don't care. Y is always 2. Okay, next, let's go. So far, so good?
Yep.
All right, so now, what else? I mean, these guys are all easy to do, you know, so I don't know. All right. All right. Oh, here's the interesting question. Let me see. Aha. Okay. Let's do this. I think this is a pretty good question. 4.1 section, okay? It says this. Let's try number 23. Okay. Now here, it's a great to organize your argument. It says this. Find equations. You know, in class, I think we can cover all this, right? That's why coming to office hours is such a smart move. You know?
Yeah.
So you can win this. This is a good question. I like it. With center to negative 3, 6. And it says that touch this part A, D, X, Y plane. P is D, Y, Z plane. D, E, X, Z plane. Take a minute and write down the, imagine, okay? Imagine. Write down the equation. Okay, good luck. Okay. All right. So here we go. Okay. All right. So now, can you write down the answer for part A? All right, everybody's type it up. See, I think whether you could type it up. Part A. Let's say write down the answer for everybody. Write it up on chatting. What did you get? Okay, I'm waiting for A. All right. Type it up. That's right. What is the something, Justin? That's the question. Yeah, look at the what Dan's answers. Yep. Okay. So we know that. Okay, very good. We know the answer is what? X minus 2. That's the center, right? Y minus negative 3, which is positive. And then Z minus 6 squared. So then you're asking what is the radius? That's the question. Yeah, 36. Think about this. How do I know? Think of this way. X is right? XY plane, right? Right? XY plane. And then think of center is right there. 2, negative 3, 6. You want to touch it. You want to make a sphere on here. So the question is, what is radius? That's the question. All right. What is this? What? The point on the plane. You drop it 2, negative 3, comma 0. Isn't that the point? So what is the R? 6. Think about it. I mean, it's a z distance. The distance from the xy. Think about this one here. X, Y, Z. This is XY plane here. XY plane. And you are here. Let's say this is ABC. You know, what is this distance here? Isn't that that's a distance, isn't it? So far so good? Okay. Yes. You got it? Okay, so why don't you guys finish this? I'll wait another minute. All right, you write it again. If you're done, and just start with the other homework problem. Okay, let's wait about 2 more minutes. You know, so that we make sure everybody gets the right answers. Okay, so use this logic, and then find the radius. Okay. All right. Take a minute. Try this. Okay, all right, back again. All right, so now part B, everyone type the answer for part B. 1, 2, 3, type it up. Yeah, all right, okay, very good. So think of this way here, you know, it is why is it plane? It's right there, right? Why is it plane? Why is it plane is, let's say, yeah, why is it plane? Why is it plane is right there. I mean, that's the here's the y plane, right? Here's the y plane. This is what y is the plane, right? So think about what is the radius when you have a point here, point A, B, C. I mean, isn't this distance or x values? Isn't it x values? Absolutely. That must be radius, isn't it? Right? This must be radius, isn't it? Right. So y is a plane? Yeah. I mean, let's not memorize anything, okay? Just use this visualization and figure it out. Yeah, it is. It is x value. Distance from point to the what? Y is a plane. That's x values. 4. Kayla, learning a lot? Yeah, Kayla, that's okay. It's just a matter of take a time. You know, one thing we should do is, yeah, questions.
Quick question. The radius of the x-axis is what makes it
Yeah,
I guess not 3D, but like, you know what I mean?
yeah. I think we could think of, you're right. I mean, if you want to touch that here, using, look at this, y is a plane, right?
Right.
Instead of memorizing, we have to think about it, what that means. It really x distance. If you want to, y is a plane, you know, it is x values, isn't it?
Right.
Yeah. So I think even though it take a time, Kayla or suggestions, I mean, just take a time. It's not the point of doing fast. Speed doesn't mean anything in math. It's all about understanding. Yeah, so don't think that you have to go fast. You know that's fine. That's not the point. Once you understand it, you become super fast. All right. So how about this question? So then, I mean, mechanically we start to learn it, but still, I wish you guys train yourself drawing this kind of picture several times. You know, don't do too mechanically. That's where did it go? This guy's run away. Where's my picture? Ooh, look at this. So take a time. Let's try this one again one more time. Let's not relate them. You know, I mean, first of all, look at individual questions. Yeah, yeah. Just show this. Take a time. Don't rush. It says XJ plane. So where is XJ plane? Well, it's a wall. It's a what? It's a wall on the left side. That is what this is XJ plane, right? Right. So then you think about the point. You put the point here. Put something like ABC. Then I think it becomes very, very crystal clear to yourself what has to be radius, right? You know, it is what? It is a y distance, isn't it? It's a y distance, isn't it? So don't say B, you know? It could be ABC could be on the left hand side. So always put absolute value, okay? Absolute value. Okay. Makes sense? So equations are obvious. X minus 2. I mean, they're all same, centers are same. Yeah, you got it? But our case point is on the left hand side, isn't it, right? Yeah, our point is what? What is this guy here? What is this guy? 2 what? -3 and 6. This guy's on the left side. This has to be what? It's on the left side, right? It is absolute -3. That's radius, isn't it? Makes sense? So it is -3 squared. So there, then it is really some charges. What do you say? Cool? Kayla, cool? Alright. So, alright. How is this office hour? What do you think this format that step one, I write down the question, or you ask me a question, then we write it. And then you take a couple of minutes, and then we come together, we discuss. How is that? Huh?
I like it.
You like it? Okay, Justin, thumbs up. All right. How about other people? Jacob, you like that? All right. Ming, you like it? Okay. Yeah, good. Yes. So imagine we work on this way. You guys impress me. Other people, 30-some people, they're gone, but you're still staying. This is how you study. Yeah, just make it part of your life. Live with it. Then you are going to make it. A lot of time, I advise people get lazy. That's why they collapse. Tell yourself next 16 weeks, I'll be consistent. Just tell yourself that you work consistently, and you get through. But this kind of subject could be very, very horrified because people fall behind. It's a nightmare, Yeah, that's what's gonna happen. Good job. So I have to go to another office hour for next class. I'll see you tomorrow. Bye bye.